When we think of properties we want to control in our systems, we most often think of complexity and performance. But you might also be thinking about security, usability, portability, and scalability. These are all other valuable properties as well. But one we don't want to underestimate is the importance of source code being readable. People, other engineers like ourselves, will have to read and understand our code after we're done with it. By making our code readable, we make it easier for other engineers to understand the intent behind our code, which will make it easier for them to understand the changes they need to make themselves, and reduces the chances of their changes introducing new faults into the code we wrote. What we really want to avoid is being frustrated by an opaque bit of code and asking ourselves who wrote it, and after checking the version control system, finding out that it was ourselves 6 months ago. Readability is so important that Janice Singer at the National Research Council of Canada coined the term code is king. The reason she came up with this notion is that readable code is documentation itself. This is especially important because documentation can become out of date, but the code that runs within the system is the ultimate spec of what the system is doing. There are a number of readability anti-patterns and goals. Let's talk about a few of them by looking at some concrete code examples. The first anti-pattern is deep nesting. So let's go back to look at the level tick method to take a peek at this. So here, if we scroll down through this method, we can see that there's a lot of nesting going on. In fact, if you go at its deepest point here, we're down into 6 levels of nesting. And this makes it really hard to understand what's going on within this method. Also up above here, we have an instance where we're 5 levels deep and we have this return that's happening, right, where we're short-circuiting the execution. So what is it about this figure being an instance of Mario that makes it worth skipping the whole rest of this loop where there's a lot of other interesting functionality going on? Why is this so important? Right, this return statement is really a problem. So deep nesting makes your code much harder to understand. Another example is within the audio code. So let's take a look at the audio constructor. So if we scroll up here, it's the constructor for the audio class. And looking at this, we also are 6 levels deep where we're setting the current time to 0 and calling this stop play. And to make this even worse, this code is actually happening inside an anonymous callback. So in a callback, in a constructor with 6 levels of nesting, we're calling this functionality. And really understanding why this is here and what's going on is really challenging from looking at this code alone. And it's really the nesting that makes this worse than anything else. If this was in a method that had a reasonable name, we'd know what is going on. Which leads us to the next anti-pattern, which is itself bad naming. So going back to level, right, when we were looking at the level here, you might have noticed this called a figure Q2Q. I don't know what that means. And from the name alone, I can't figure it out, right? It doesn't give me any useful information. So to figure that out, I actually have to go to the Q2Q implementation and read the code. And after I've read through all of this code, I can tell you that if 2 figures are far enough away from each other, either horizontally or vertically, we return false. Otherwise, we return true. But really, we shouldn't have to read the implementation to understand what this method is doing. This terrible name, Q2Q, is not helping out any future developer who wants to understand what's going on within all calls of this method. We see a similar thing within Mario if we're taking a look at the death method. And we're trying to understand how it works. Because here within this method, we can see all kinds of references to death begin wait, death end wait, death dir, death frames, death count. I don't know what these things are. And if they had better names, it would be much easier to understand what's actually going on within this method. And you can see these fields being all lumped together up here in the field declaration section of the class. And again, if we had much clearer names here, it would be easier to understand how this functionality works for anyone else who's trying to fix this in the future. Another anti-pattern for software is when the code shows a lot of individual style, and this is one thing that Mario is great at. If we look through this code, we can see that it looks like it's been all written by the same person. The style is consistent across the entire code base. And this really makes it easier for new people to make modifications to the system that really fit in with what is there before. Well, we might want to think that individualization is a good thing, right? Having our software seem cohesive and written by a single person or a focused team is always better because it makes the code easier to understand and modify. Another anti-pattern within this code, though, is the complete and utter lack of comments. There really should be some documentation within the code to help us understand what the key types and methods are within this system. One goal for readable code is we want the code to read like natural language. So if we take a look at star and read the hit method here, it is really a readable method. We can say, hey, if this star is not taken and it is active and it's been hit by Mario, then Mario becomes invincible and the star dies, the star goes away. Right? This is extremely readable and it's super clear what is going on within this method. If you just came upon this method yourself, it would not take you any time at all to really understand what's happening. I also want our code to be structured in terms of digestible chunks, kind of like paragraphs within a book. So if we take a look at figure move here, we can see that this method is coordinating 8 different fields and a few different objects, and it's really not super digestible. It's not easy to look at this code and have a complete understanding of what's going on. Right? This code would definitely benefit from being broken down into more digestible pieces. And here we can see that this seems to be a significant block, as is this loop. And this final check here, right? It's easy to imagine this code being broken down into 4 or 5 individual steps that would be much easier for a future engineer to understand. Another thing we want to do is we want to write our code in a way that explains itself. So if we take a look at the death method here within Mario, we have this line, return bang bang minus minus this dot death end wait. I have absolutely no idea what this means, and if you're a new developer who's trying to fix some problem with the way that Mario dies within the game, this is going to be a challenge for you. Finally, we want our code to be able to tell a story. So if we take a look at the grow method here within the Mario class, we can see that this code really explains. It acts as a spec for this functionality. So if the state of Mario is size state small, then we're going to play the grow sound, we're going to set the state to be big, and we're going to blink 3 times. And if, for instance, Mario is in size state big, nothing's going to happen. Right? The code here really explains the spec of what's going on. This is really a clear story of how the grow functionality works within the game, and is a great example of what happens when we write our code in a way where it tells its story clearly and succinctly.